In this recording, we're going to talk about the basics of Edgeworth box diagram. We're going to talk about what is Pareto efficient outcome. What do you mean by the set of Pareto efficient allocations, which is contract curve, and a very simple proof for a differentiable utility functions where what is the condition for Pareto efficiency, which is MRS1 is equal to MRS2, where individual 1 and 2 are named as 1 and 2. So let us just start. Let us say that this is a 2 by 2 economy. So there are two consumers, A and B, and there are two goods, X and Y. So in the economy, there are two individuals, A and B, and there are two goods, X and Y, right? A's endowment is WAX, WAY. B's endowment is WBX, WBY. Endowment is this is what we are born with. We are endowed with this much amount of X and Y. So there is no other production which is taking place, no uncertainty, nothing. So it is just an endowment economy. You and I are born with certain amount of X and Y, and there is no extra income which is coming from anywhere. And then we are trying to trade that whatever we are endowed with, now we will trade. Should we trade in the sense that should we go to the point where both of our utilities are increasing or at least one person's utility is increasing? So let's look at that. So I'm just telling you the meaning of endowment, that you're born with this amount. I'll make your life simpler. So what I'll also assume is that I'm going to assume a differentiable utility function. Say for example, individual 1 has the utility function xy. You can also call it as or I should rather write individual A, UA as XA, no, YA, and UB as XB, YB. So I will generally write this as only XY and this as XY. So I won't be writing the subscripts again and again, but this is what it is. And what we are also going to assume is, let's say E1 is what? 2, 8. E1 means, okay, I'll write EA. So I'm accustomed of writing E1, E2. Okay, EA. EA, or you can write WA. Endowment of individual A. Endowment of individual B is 8. So we'll write the theory and the example side by side so you understand it well. Right. So I am born with 2 units of X and 8 units of Y, and you are born with 8 units of X and 2 units of Y. Right? Fair enough. So after the trade, what has happened is that my consumption bundle is the XAYA. So I'm individual A, you are individual B. So I am consuming X and Y, that is XAYA. And you guys are consuming XBYB. So this is what we are endowed with. This is what we are starting with, and this is what we are ending up, right? So this pair XAYA and XBYB is this pair of consumption bundle is what we'll call as allocation. Hmm? This pair of consumption bundle is what we call as allocation. What is the feasible allocation? Feasible allocation is the one which tells you the amount of X, total amount of X which is demanded is equal to the total supply of X. What is the amount of X which I am demanding, beta? XA. What is the amount of X you are demanding? XB. What is the total supply of X? That is the amount of X I am born with plus amount of X you are born with. That is endowment of X which I have plus endowment of X which you have. That is W AX plus WBX, right? Similarly, how much of Y I am demanding? YA. How much of Y you are demanding? YB. What is the total supply of Y? The amount of Y which I have as an endowment plus amount of Y which you have as an endowment, right? So total, this is total amount of each good consumed is equal to the total amount of each good available. है ना? So this you call as feasible allocation. So it should not happen that you are demanding more than what economy can supply. So that is not a feasible allocation. That is, this is what is feasible allocation. Hmm. So this is what your demand side is. Just keep this thing in head. And this is what your supply side. Hmm. Okay. Then we need to find out an equilibrium price vector. Acha, one more thing. In terms of these guys, the example which we have taken, where I am endowed with 2 units of X and 8 units of Y, and you are endowed with 8 units of X and 2 units of Y. So, what is the total amount of X which I have? 2. What is the total amount of X which you have? 8. So, the total supply of X in the market is 10. Similarly, total amount of Y which I have is 8 plus total amount of Y which you have is 2. So the total supply of Y in the market is 10. So we'll talk about how do you get demand, but I think it will take some time to reach till that point. But this is the total supply of X and Y in the economy, right? So we are interested in finding out the equilibrium price vector. At which market clears. That is equilibrium price of X and Y. So we are interested in finding out what is this equilibrium price. We will have to come to this point. This is just the first class here. Now, how do you draw the Edgeworth box diagram? How do you draw the Edgeworth box diagram? So Width of the box, you don't have to write this much in the paper. It's just the first class, so I'm just telling you the basics. And of course, nobody is going to ask you uh, to write what is the width of the box. They'll just give you a numerical question to solve. But you need to know the ABCD of all this. So width of the box is the amount of x which I have plus amount of x which you have. Height of the box is amount of y which I have plus amount of y which you have. हाँ बेटा. Okay. So, how should I say this? This is what I'm going to start with. So this is the amount of x which I have. This much till here. Hmm? And this is the amount of this one, only this one. Please don't make the diagram like this. I'm just making you understand. So that is the reason I'm drawing it this way. This is WBX. So I'll rub this. I'm just telling you how do you write this. So, and so this is my origin, OA. So if I'm going to start from here, this is your origin, beta, OB. So you start with this point. Beta, this is what WBX, na? This is what you're endowed with. Guys, hello. This is what I have, amount of X. This is what you have as an amount of X. Total amount of X is what I have and what you have. So that's a total thing. So till here is what your endowment, and this is what I have. This one. Everything will make sense. I mean, just bear with me for 2 minutes. Okay. This is only what I have as the amount of y, WAY. Let's say WAY. And let's say, and this is what you have as the amount of y, the remaining. Beta. So the total height is how much? WAY plus WBY. You with me? You understand what we did? Hmm? This is the amount of y which I have. This is the amount of y which you have. Don't worry about the example which I have taken. I mean, I've just taken that in order to make you understand few things. So I'm not drawing it to the scale there. I'm just telling you how, let us say, these are the positionings. So this is the way you draw the Edgeworth box diagram. So I just want to tell you in this that what is the width of the box? The total amount of x. What is the height of the box? Total amount of y. And total amount of y means the amount of y which I have plus amount of y which you have. Beta, I'm sitting here, here. Amount of x which I am endowed with and amount of x which you are endowed with, right? Hmm? And you guys are sitting here, the amount of x which you are endowed with and the amount of y which you are endowed with. You with me? So you read according to your x's. Your x's is this, beta. Sorry. So you read according to your x's. Your x's is this. So you read like this. So your x is increasing in this direction. Your y is increasing in this direction. You read it like this. My x is increasing in this direction and my y is increasing in this direction. That is my axis. Are you with me, all of you? This point is called the endowment point. This point is called the endowment point. Of course, there can be only one endowment point in the Edgeworth box diagram. There cannot be more endowment points in the diagram. So there can be only one endowment point in the diagram, right? Okay. Now, if I just want to draw the curves, let us say. So let us say, ta, ta, ta. Okay. Does it look straight? Let's say it looks straight. So this is my origin, beta. This is your origin. Uh-huh. What is my endowment? You remember? 2, 8. What is your endowment? 8, 2. Hmm? What is your endowment? 8, 2. Right. So let us say I start here. This one. So this is 2 and this guy is 8 out here. So this is 2, 8. So I'm sitting here. Reading it from your side. So this much is 8 from your side, right? From your side, it is 8. Guys, this is not from this. So you are reading it from your axis, 8. From your axis, I'm again and again telling you, don't be confused. And this is reading it from your axis, 2. Reading it from your axis. So when I'll be putting the allocations, I won't write it like this. So I'm just telling you, how do you put the endowment out here? Okay. We assumed something else also. UA is XY. UB is also XY. That's what you have assumed. So what you can say, supposedly if this is my endowment indifference curve, UA. Acha, one more thing. So this is 2 here, and from reading here, this is 8. So the total supply of X in the economy is 10. This is 8 here, and reading it from here, you're 2 here. So the total supply of Y in the economy is also 10. So this is what the width and the height of the Edgeworth box is. Okay. What about this? Your curves. Guys, one more thing. Sometimes while doing this, you just forget that if I'm going to draw according to my axis here, so this is the way I'm going to draw the curves now. My curves will be growing in this direction. This one. That's right. You are also Cobb Douglas. I'm also Cobb Douglas. You're also Cobb Douglas. Your axis is like this. So your X is increasing in this direction. Your Y is increasing in this direction. Right? So what happens? Your this thing is increasing in this direction. So your curves are going to move like this, beta. This. My curves are going to move like this way. Okay. Let me just rub this. So this is my endowment curve, and let us say this is your endowment curve. I hope you know this, that this is the way your indifference curves are going to move now. So endowment curve would mean which is that indifference curve which is passing through the endowment point. That is what the endowment curve is. That is what the endowment curve is. Fair enough. Acha, you tell me one thing. I, what is the better off region for me? Hmm? Let me just, for the very simpler version like this, I'm going to draw it like this. Okay? So that it becomes easier for you to think. Okay. What is the better off region for me? This one is the weakly preferred region. So I will not have a problem moving in this region, right? I will not have a problem moving in this region. Yes. What about you? You will not have a problem, beta, moving in this region. है ना? Because all the indifference curves for you in this region will be a higher indifference curve. For me, all the indifference curve in this orange region would be the higher indifference curve, which are giving me higher utility. There is an intersection of our regions, of our better off regions. है ना? There is an intersection of our better off regions. So, don't you think that both of us can actually move in this lens shaped area and increase our utility? We can. So, there is a possibility of trade which is there in this particular region. So this lens shaped area is telling you that there is a possibility of trade out here. I'll be coming back to this lens shaped area again and again in various examples. But you need to understand this that yes, there is a possibility of trade out here. Acha, you tell me one thing. I I I hope this is clear, beta. Because let us say my indifference curve in this region. Let's say I move to this point, C, right? Let's say this point is C. I hope this is visible. Okay. And you move in this region. How about this thing? I'm not even telling you whether what kind of allocation is this. Is this a Pareto efficient allocation or what? Nothing. So I have moved to this point and you have moved to this point. And we are consuming out here at this particular point. Achha, one more thing. I move to UA dash, you move to UB dash. Compared to UA, my utility has increased. Compared to UB, your utility has increased, right? Okay. Now you tell me one thing. When I move from point E to point C, at E, I had how much of X? 2. Let us say you move to this point. Hmm? So at E, how much of X I have? 2. Let us say at, oh, just wait. And at C, how much of X I have? 4. And at C, how much of Y I have? 6. So compared to the endowment point, compared to what I am born with, I have more X. I want more X, eh? And I want less Y. I'm ultimately consuming it, let's say at point C. So I am buying more X. So I am net buyer of X. And I don't want 8 units of Y, I just want 6 units of Y. So I have given up 2 units of Y to get 2 more units of X. So I am a net seller of Y. I am a net seller of Y, right? Achha, compared with this, what about you? Compared with this, what about you? Yours. Hmm. So what happens? Let's say this point is 6 from your, when I'm reading it from your axis, and this point is 4 when I'm reading it from your axis, right? So you were born with 8 units of x, but you're consuming ultimately 6 units of x. So you don't want that much of x, right? Here, you were born with 2 units of y, but you want 4 units of y. So you want more of y. So you guys are the net buyer of y. I am, sorry, and the net seller of x. I am, sorry, you guys are the net seller of x. So I am the net buyer of x, right? I want more of x, which is what I'm endowed with, and I'm the net seller of y. I want less y of less of y what I'm endowed with, right? That is what it is. So these are the basics, very basic of the Edgeworth box diagram, right? In the next recording, we're going to talk about what are the Pareto efficient allocation. And I'm telling you, this is one of the Pareto efficient allocation. So we're going to start from this particular point in the next recording, where how do you how do you define Pareto efficient allocations? What are Pareto efficient allocations? And what is a set of the Pareto efficient allocations? Right? Okay. So this recording, we have just learned what are the basics of the Edgeworth box diagram, right? How do you draw this diagram? Hmm? Okay. Thank you.